everybody! How are you doing? Listening to the whole universe. Hope everything is fine. And I'm a Russian man who brings value through my own experience. And today we're gonna communicate with you about word2vec technology. It is when we connect specific words to the specific vectors, to the specific sets of numbers. Wow! And to illustrate my example, let's dive into these Cartesian coordinates. We have x and y coordinates here, and also we have some words. For example, frozen, ice, and water. And they are synonyms, and they are placing to each other so similar. They are kind of here, here, and here. So numbers of them, they are so similar. I imagine, again, a Cartesian coordinates, okay? And here it will be fire, flame, and inferno. It will be another thing, and they will be antonyms for each other, but for themselves, in these groups, in these clusters, in these sets, they will be similar. So the distance between them, Manhattan distance, or maybe Euclidean distance, or the squared Euclidean distance, or other distances, they could be kind of smaller, and here it is, everybody, and they are kind of the same almost. And this will be for them will be not the same, but for them they will be similar. For them it will be dissimilar. So it is antonyms. One more example with different types of cities. For example, in China, okay, and here it is, Chinese cities, cities of China. We have Nanjing, Beijing, Peking. It is another name for Beijing. For example, we have Nanjing, Beijing, Shanghai, also Tianjin, and Guangzhou, and they will be similar to each other. It is kind of, they are kind of in one country. It's fine, it's good, they are similar. But if we will take, for example, another cities, but in another country, for example, the US, there will be Austin, Dallas, New York, and also maybe states, New Jersey. Yes, and some of the toponyms. It could be not only cities, it could be toponyms, and as in China, for example, we can use not Guangzhou, we can use Guangdong. It will be province when inside of it we have Guangzhou. And the same with states. For example, we have Tennessee, or maybe Texas and California and Milwaukee and others. It will be another things, and actually they will be dissimilar to each other. And if we will take, for example, Italy and Rome and things of this nature, it will be in another cluster. For example, we have Russian cities. So let's switch a bit of inside of Russian. We have Клин, Серпухов, Tula, Kazan, Moskva, and etc. And we have different types of cities actually in Russia, and we have different types of places, and it is how we roll, everybody. So, and we have different cities, they are in different clusters, and they are placing in different places, because they are similar to one country, but they are dissimilar to another country. But they could be a little bit of similar if we will talk about capitals. For example, we have Moscow and we have Russia. It will be right now will be countries and their capitals. For example, we have specific yes, it will be Russia and Moscow. Here is Zhongguo, it is China, and also Beijing, or maybe Peking. Yes, and we have here it is, and also we have, for example, Germany and Berlin, and also France, Paris, and they will be parallel to each other. It is one more interesting example that can show to us something maybe familiar, because it is kind of, in this row we found all the capitals, in this row we found all the countries, and it is all about our word2vec representation of the data. And to us as the people, it is visualization of it, but visualization, it is all about numbers. We can visualize any types of numbers on 2D space, or maybe 3D or 4D, 5D, 10D, and etc. And word2vec technology used in different types of voice assistants. When we say Siri, hello Siri, do this, or Alexa, do that, or maybe some Russian things. Yes, so do that, do this, and everything will be fine. Yes, and also we have technologies of machine translation. When we translate from one language to another, it will be used there too. Also different types of annotations to the pictures. We have pictures, for example, and we have annotation. For example, here it is. So you see my face, for example, you can say, yeah, I'm a human, yes, and kind of this way. It is hands, yes, it is fingers, and all depends on the Euclidean distances, and also different types of metrics that we use. Metrics, METR, yes, and etc. METRICS, yes, metrics. What types of metrics we use and what's the precision of this metrics we use. Similarity measures. Yes, we have Euclidean distance, Manhattan distance is squared Euclidean distance, and also Mahalanobis distance, and Chebyshev distance, and Minkowski distance, Manhattan distance, and Kullback-Leibler divergence, or Kullback-Leibler distance, or also we have one more coefficient for cosine similarity, and etc. And actually it is different types of measurements that we can use in this type of word-to-vec clustering when we use different words. Actually we also have technologies for NLP, NLU, NLG. It is we have word-to-vec and doc-to-vec. It is for them, and where they are used to in BERT, Roberta, Albert, DiselBERT, XLNet, Transformer XL, GPT, GPT-2, GPT-3.5, GPT-3, GPT-4, ChatGPT. In these technologies of large language models they are used to, and also in another technologies we have different analogies for it. For example, pile-to-vec, tile-to-vec, patch-to-vec, log-to-vec, item-to-vec. It is almost the same. When we one thing compose and kind of replace by the numbers, by the sets of numbers as presented in vectors, in linear algebra, for example, yes? And so, guys, today we talked about word-to-vec technology. Hope you enjoyed it. Leave in the comment section below what did you learn, and what have you learned, and what you want to see in the next videos. And I will do this, and thanks so much for watching. Have a good day, everybody, and everything depends on you, only on you. Be a nice girl and or a man, and yes, be a nice man or woman or girl or dude. Yes, be a nice person. Go forward. Everything depends on you. Yes, cheers and hugging you. See ya. You're a nice guy, a girl. Bye.